Well, thank you so much. Thank you, Dr. Caleb, for introduction and the vision, and Carlos. And thank you for having me here today. I have a couple of updates for you. Of course, open data happens in light of Forrest Gump. Last year, exactly about this time, I announced that we're about to launch the openFDA initiative. This is our sort of transformative and open initiative to transparent agencies. So let me walk you through the year-long journey about where we are right now. The whole idea from the beginning has been how can we spur innovation not only within FDA but also in the community, and how can we be transparent about doing this by reaching to software developers and researchers, not only to unlock the data that we have but also create a community around it. And in this sense, these are sort of the three legs that our stool stands on. It's not only putting data out there, it's open data, but also build the community. And anything that we do with this information is make it available in the open source. To start with is we create what we call application program interfaces, APIs to allow software developers and researchers have better access to this information, easier and more unified access to our drugs, food, and devices. And this is really modeled after mending walls. Good fences make good neighbors. We didn't want to go and develop applications and apps. We want to build APIs and a good platform, common platform that is open so everybody can play sort of in the sandbox. This is the way before openFDA. You really had to know, understand, be a very expert database person and understand the hierarchy and organization structure of FDA. But with openFDA, really, we transformed this. Is we want to seek your interests. You might be interested in drug labeling, or the device adverse event, or food recall. So we want to make sure that we model this, with your interests, but also give you information in one unified standard approach. We built a very strong and self-correcting community around the data. And these are just some of the ways we have to work directly with the community. We have a dedicated Twitter account at openFDA where there's a lot of interaction happens. This is also the first place we learn if there's a bug or if there's a new app or a new solution that's being built on our data. Stack Exchange is really, this is the open question-answer forum that we built with the community, and we try to be as neutral as possible. A lot of the interaction you see on the Stack Exchange around openFDA is not coming from an FDA person answering question, is rather another community member who's answering the question. And of course, the entire processes and entire software that we built openFDA on is out in the open on GitHub. Also, we have an API status page to know whether the APIs are up or down, or we're working on those, and tons of interactive documentation. This is where you can learn how to code for openFDA and also see the results, how that might transform before you can start working with the data. Want to emphasize, none of the data we have has any personal identifying information. We start with already public data, but we prioritize based on the interest. There's a lot of discussion inside FDA and also with the community about which data sets should we make available in this sort of approach using the APIs, and also which data should we harmonize and interlink with. A few criteria that came about, for example, a lot of data a lot of requests we get, the FDA, what we call the FOIA, Freedom of Information Act, so those kind of get a priority. Also, what's more important is which data sets can cross or span across multiple domains, and our, of course, agency span across multiple centers. So we have right now an openFDA offers you close to 70,000 labeling for drugs, whether prescription or over-the-counter drugs on the market. Close to 4 million adverse event records for medical devices go all the way back from 1991. More than 40,000 recalls of drugs, food, or devices. And of course, about 4.6 million records for the last decade of adverse events to drugs, including over 90,000 drug mentions, close to 13,000 indications, and more than 16,000 side effects. Now, we're continually working on adding additional data sets or harmonize the data we have. For example, right now we're working on registration and listing for medical devices, among other things. So we're just listening to the community, what's being discussed on Stack Exchange, what we heard from Twitter, followers and whatnot, to see how we can prioritize the next step. Of course, making the data available and being transparent is very simple documentation in terms of use, how you can start using this information. So that's the first step that you'll encounter. I received a lot of great feedback how wonderful this sort of terms of use has been as a model for others to follow. There are 3 steps to use openFDA. This step is optional for occasional users. However, if you're a heavy user, this is how you can register for an API key. As simple as add your email address, and then you register, you received a key from us. The second step is really learn how to work with the APIs. We understand this is where we use Lucene sort of language. It might not be intuitive. So we provide a sort of self-correcting way of how you can learn the language of the openFDA APIs. Here's how you search. Here's how you analyze. And then as you type that query, automatically you can see the results. If you get some error, it'll tell you like why the error was there. And you can just point and click on different examples that were provided to us by the community or our team has put out there. And that really gets you. When we spoke to the developer community, this went from before openFDA would have taken 2 years before they understand which data set to link and whatnot, to literally less than 20 minutes you're up and going, and you have to just learn how to just kind of learn this, how to query the database. But if you need to know where the data came from, how we modified the information, detailed information about the values of each field and whatnot, we have that on the site. And lastly is meet the data and start coding for the data. That's the last step. This is when you start building apps. This JSON format is very common and open standard format, but also sharing of that data. Now it's as simple as sharing a URL. There's quite a bit of innovation that went inside the making of openFDA, anywhere from creating a scalable infrastructure on a cloud-based infrastructure. The day we went live on June 2nd, 2014 last year, we sustained over 100 queries per second per APIs. In the first few days, we received over 1 million API calls worldwide, and the system scaled, and we were able to continue to be live. Also, there was quite a bit of innovation around a search approach to big data and analytics. We're among the first to use Elasticsearch and contribute to it. A year later, now we have over 1,500 government websites use Elasticsearch, not to include the industry. The agile and user-centered approach, we involved a focus group from inside and outside FDA that we worked with throughout the process to help us design the documentation, help us design the APIs, also the interaction with the information. And that sort of new approach now to interoperability and access is being evaluated inside FDA, how we can access internal data. Elasticsearch, for those who are not familiar with, this is what powers Wikipedia and GitHub. If you search on Wikipedia or GitHub, this is sort of like the base search engine. I mean, think of it as, and this is for us as the database. Think of it as like a Google, but for documents that you load. And it's really great for unstructured, semi-structured text, which sort of drive most of the data that we have. Node uses the same JavaScript engine as you have in your Chrome browser. So we use that to run the API's servers. And it's a great fit for that because it supports JSON, which is sort of like the common the format that we use to exchange the data. The music engine, Spotify, everyone is familiar with that. So we use Python, a library that powers the ranking of the musicians and the music on Spotify, Luigi, which is open source, to help us sort of orchestrate how we can get all the data pieces together and harmonize before we load it into the Elasticsearch database. And lastly is monitoring the APIs from registration keys to rate limiting to the quotas or to the analytics. We use the API umbrella, and in particular the instance that the White House GSA hosts, and that's what part of our technology stack. So all open source. So I mean, you can think of openFDA as this highly distributed, scalable, RESTful search engine. Our philosophy from the beginning has been go anywhere open source. So we or you can run API servers for openFDA anywhere because we use the Docker technology. This perhaps is the most important step in the entire process of openFDA. This is sort of the data janitor step. The data that we have, the raw data that we deal with, it's multi-format. Some even have archaic formats that no longer supported by the community. So we look at all these data sets, and we convert all those into an open and common standard JSON format. And then once we do that, then the annotation starts. This is where we add keys that you're familiar with, such as the Unicode or the NDC code or UPC code or RX norm, so to allow you to interchange data, for example, electronic health record. And once we go through this process, then we load that into the database, so you have a fully harmonized and interlinked data set. But what's really important is many don't know that FDA is a scientific organization. So to stay true to our scientific mission, this is very important for researchers. From the beginning, when I say I want to spur innovation within software developers and researchers, now you have the entire pipeline, not only the software, but also the process is open source on GitHub. So you can actually reproduce the results if somebody wants to challenge how you came about deduplicating the records, linking the records, you'll be able to kind of see the whole process, and you'll be able to reproduce those results. Many of the steps here for cleaning the data and linking the data wasn't just our team and FDA experts. Actually, the community on GitHub and on Stack Exchange has contributed quite a bit of this. The top 40 developers of openFDA right now are not FDA employees. They're community members from all around the world. So, for example, this is what a adverse event record might look like. You can see here there's an openFDA section. This is the annotated section. This is the metadata that we add to the original record where we harmonize. That will make it really easy for you to find the record regardless where it came from. This also is a great challenge for you guys to think about, for example, medicinal products, the names. 10% of the data adverse events comes directly from consumers. And oftentimes there's a misspell of those names. So this is a really great area for enhancement as well. For enforcement reports or recalls, we look at, we use data mining techniques to extract NDC code and UPC codes. Oftentimes UPC codes or the barcode is missing, so what we do is scour Google images to find high-res images of the boxes where we extract the UPC code and then add it back to the recall record. And that, if you develop an app where you can scan a bottle or something like that, this is how it happens, where it brings that record back to you. So, for example, for drugs, these are many ways you can search for a drug right now. Adverse event by brand name, by trade name, by active ingredient, mechanism of action, even chemical structure, you'll still get something back. And this is, by the way, for the first time, adverse events of drugs that FDA has on publicly that are searchable on all the standard fields of a labeling. The timeline was very aggressive. Upon me joining FDA 27 months ago, on March 22nd, I came up with a concept, and I worked several months to socialize that inside FDA and with the community. We started, the wheels start kicking, so to speak, on September 1st, where we started software development. And even though we got the shutdown of the government for almost a month, we still delivered on June 2nd with the first data set around adverse events of drugs. And then throughout the summers, we start adding the rest of the data sets. The API strategy that we have and the portal that we built was lauded by API strategists as a good model how government is building documentations and APIs to reach directly to the software developer community. While we're still in nascent stage, we really do believe that we have or are providing great service to the global community. Over 20,000 IP addresses connected to openFDA right now. More than 6,000 registered and active API users. 11 million API hits since June 2nd last year. Half of those came from outside the United States. And what we know from the community that's been shared with us on, via Twitter or on Stack Exchange, over 30 new apps being built on openFDA. So let me share with you a few of those. The very first Open EHR or EHR sort of module linked directly to openFDA. Here's one example. Another one, there's many search apps being built on top of openFDA just to find the information. This is one of the apps actually is more consumer focused. This is where adverse events like me, so to speak, I'm experiencing an adverse event that somebody else has the same thing. So you can register for any changes to the label or adverse events, but also they built a community, a social network community around adverse events, recalls, and labeling. Here's another one was designed and built over 1 weekend by a medical student, second-year medical student at Leeds University in England that searches across gender of adverse events and was able to normalize the results set. Early this year, we had the very first codeathon for FDA, around openFDA. We had 70 people showed up and to learn the APIs over 2 days. And this is really the first thing that they came up with. There was a lot of dashboards. And of course, a good dashboard really is one that helps you ask more questions, not necessarily just answer questions. You can even see one mobile app was developed by a reviewer. A week after the codeathon, one of our team members was able to post an R library to connect directly, our statistical package library to connect directly to openFDA. And this is really phenomenal because FDA doesn't have to kind of decide what kind of new app is going to build. The users are already doing this on top of what's already open. As a matter of fact, a biostatistician, Dr. Jay Levine at FDA, was able to put this R statistical package using Shiny with another open source to do analysis on adverse events or drug event interaction as well as time series analysis. But it's very important to understand that the data that we have may in itself not provide the complete picture. And this, again, why we build the community in the first place, is to be able to avoid or hopefully prevent, to the extent possible, any misinterpretation of the data. And we've seen how the community jumps in to help each other about, oh, you might not have issued the right query. Here's the way to write a query. Or you interpret this information this way, but there might be additional things that you need to think about. For example, does aspirin cause flushing, or is it an innocent bystander? So let's see in this example provided by Jay.
The first program I wrote lets you input the generic name of the drug, and then it calculates the most disproportionate adverse events for that particular drug. In this case, we see that flushing is the most common adverse event for aspirin. So one question you might have is what drugs are given along with aspirin? And we can see there's aspirin, a number of lipid-lowering and antihypertensive drugs, and particularly the drug niacin. If we look at what sorts of drugs are associated with flushing, we can see that niacin, Symbicet, and niacin are two of the top drugs associated with the adverse event of flushing. We can look at reports of niacin and flushing over time, and we see that they've always been fairly disproportionate, but they really started to increase dramatically around 2008. Similarly, aspirin increased dramatically about that time in a similar pattern. If you look at just the gross number of reports, you can see that they also increased for niacin, and similarly they increased for aspirin at that time. Okay. So I think the conclusion we can have is that aspirin doesn't cause flushing, but maybe more flushing causes aspirin.
So if you're taking niacin, most likely a physician will prescribe aspirin to prevent flushing. So aspirin in this case is really more of a guilty by association. The last point here on this is about 10 days ago, we issued the very first public challenge. No judges, no prizes. It's really more open competition in a sense that to tell the community we're here to help you. Work with openFDA, and by way of, if you develop something, please share it back with the community using the hashtag openFDA challenge. You can start with level 1 and see how far you go, and would love to see you guys sort of contribute to that. And I just have a couple of points now I want to mention about a topic that you all talked about here. So as you all know, next generation sequencing has brought big data to diagnostics. This, of course, brought new regulatory issues that FDA has to deal with. But under the Presidential Precision Medicine Initiative, we have few approaches to address these issues. For instance, earlier this year, we conducted a public workshop where we asked for public input, and we received a number of proposals. One of these proposals is around a public informatics platform to deal with the software, the test using NGS to produce the results and the accuracy of those results. And we believe these approaches or proposals that we received will further enhance the community, but also advance the science. For example, we believe it will make it easy to validate a test, at least for some intended uses, as well as check NGS informatics platform pipelines, as well as reference data, and ultimately see if that can make it back into the platform for the rest of the community to work on or review. Here's the URL. We continue to welcome your feedback and input on this, and Dr. David Litwack is the point of contact. And lastly is building on a success that we've had with the openFDA community. So similarly, we're thinking about how we can have the precision medicine public platform. So this is our vision for what it might look like for the informatics platform as well as associated software. We're envisioning a public cloud-based platform that provide access to analytic pipelines as well as data using APIs, among other means. This will allow us to build a community around the open source as well as the NGS pipelines and data reference, be able to allow us to provide processes and resources for the community to build, test, validate, execute, and ultimately share pipelines and reference data and share it back with the community. And of course, do all this in a secure and compliant ways to protect not only the data exchange, but also any intellectual property might be exchanged with FDA or other members. And if we're invited here again next year, hopefully we can share with you our scientific regulatory experience with this rather fascinating and growing field. Thank you so much.